Okay, good morning, everyone. Thank you for the invitation. So I will talk about some general issues, but I will divide the floor with Professor Silvia Ronchi that will speak after me. I am Professor of Urban and Landscape Planning at the Department of Architecture and Urban Study of the Politecnico di Milano. I will also like to introduce the research lab where I am the director, the lab PPT, that is the acronyms of Plants, Landscape, Territories and Ecosystem Services. I direct, and Silvia is the coordinator together with Stefano Salata. I would like to introduce some general issues that are strictly related to the work we are doing in the lab, and also is related to the work we try to put in the research, in MB South research. The issues and the topics that I will deal with are, I think, important in what I think is some topics that we address within the lab that are related to a perspective to modify, to change the paradigm of spatial planning in Italy in a new perspective that is able to face the climate change issues, and so we can say in a resilient and adaptive perspective. The topics that we work mainly are ecosystem service-based planning, are urban and landscape plans at the different scales, land take processes, analysis of the impact of land take processes in Italy and mainly in the Lombardy region, and also the design of green and blue infrastructure for human well-being, and also the adaptation of a nature-based solution to implement the content of green and blue infrastructure. Some general statement that I would like to share with you is what is the new urgency for spatial planning is strictly, as I mentioned, related to the impact of climate change of our life, of our cities, of our territories. And we need to modify the paradigm of spatial planning in order to address these issues in a new perspective, putting the ecological issues in, we can say, as a focus of the plans. Another point that I will deal with is about the necessity to adopt a transdisciplinary methodology in planning. I mean that we need to work with the other expert in the environmental sciences, in botany, in agronomy, in geology, hydrology, and what else. We need to work together. We need to learn how to work together in design new, we can say, new scenarios or new strategies for the development of the cities and our territories. Another point is the scales. We have to learn how to work at different scales. It's necessary to be able to take together large scale, territorial scale with a local one to valorize the ecological issues that I will deal in the next slides. And last but not least, the role of new tools. I will talk about the sustainable infrastructures and the nature-based solution as new tools we have been planning to modify and to improve the quality of our project. These are other points that I'm sorry to be very assertive in somehow, but I try to be very quick, and so I try to define some concepts that I'm sure will be also addressed in the next presentation by my colleagues, by other scholars, and so I'm sure that they will be more in depth in explain some of these issues. But what I want to say is how spatial planning should be able to modify its model, its traditional model that in Italy is based on the land use regulation, and we have to change, putting, as I said, at the center of the project, a new approach that is an ecosystem-based approach in order to understand and valorize the quality of soil as a precious resource that we have to protect, and also to enhance in terms of services that soil is able to supply for the quality of our life. starting from an ecosystem services mapping and assessment, we can design a new kind of, we can say, a structure for the strategy of the plan, that is the green and blue infrastructure tool, that is how to say, a network of open spaces, natural, semi-natural, agriculture, and also including some part of the open spaces within the city that are able to supply services very important for our well-being. And so in this sense, we need to protect the soil, to limit the land take, and to increase the multifunctionality of the soil. So we have to change also our behavior, our habit in considering the soil as a multifunctional resource. So in this sense, I mean that green infrastructure can be a new structure, new spatial bones for the urban and ecological re-urbanization of the contemporary city, able to address the issues, the pressures related to the climate changes. These are other points that bullet point that I would like to very quickly pass through with you, is about the role and the character of green infrastructure. Is a new tool within the plan, but also as we can say a planning strategy able to implement different solutions, nature-based, that we have to use, we need to use to implement the permeability of soil, to implement the green, the amount of green areas within the city, the performances of the built environment, but also the ecological performances of open spaces. But the currency with the green infrastructure strategies is what we need to use the right nature-based solution in relation to which is the aim we want to achieve. In this sense, one of the aim, preliminary, but I think most important aim, is to improve the delivery of ecosystem services in the different character that they have, the regulation, the provision, the cultural ecosystem services that are important, as I mentioned, for our well-being. What are green and blue infrastructure is very clear in the European documents. So we have a lot of information about what we need to design if we wanted to tackle with the green and blue infrastructures, but also we know how are important in the production of different typology of benefits: environmental benefits, social one, climate change adaptation and mitigation benefits, and also the improvement of the biodiversity in our city. Is a composition of different kinds of soil with the different functions. Each function is very important, is very precious for our life within the city and within our territories. To conclude my, I hope, rapid intervention, I would like to mention two research works that we carried out during the last 5 years in the research of the Lab PPTA. And I would like to mention two different scales, also to touch the issues that I present at the beginning of my introduction. So the importance of the scales of this kind of approach. This is the landscape plan of the Lombardy region. We work with a large team. I have no time to present everybody involved in this project within the department, but me, Silvia Ronkin, Stefano Salata, and the other colleagues of the lab were involved in this work in the last, we can say, 5 and more years. And the part of this work that I wanted to share with you is about the design of the green and blue infrastructure. That is the principal landscape structure of this research and of this project. This is what we did, is a general analysis. We we carried out a lot of specific analysis about the different characters, landscape characters of the region, but for the design of the green and blue infrastructure, we work mainly about three different layers, three different levels of investigation. The naturalistic, and so we can say the habitat quality of the different values of habitat quality in the Lombardy region, the quality of the rural landscape that we measure, taking account the different characters of the landscape that are related to the anthropic part of the landscape, but also the natural one, and how is also present the different character in the Lombardy region that is very articulated in the different part of the region, of course, but we try to synthesize the value of this kind of landscape. And the third one is about the historical and cultural landscape, so how is important for our identity, for our sense of belonging to the different part of the region. And so we try to measure and to map also this kind of information, combining this different level of this different layer. We try to synthesize a map of the value of the landscape and the natural and anthropic point of view of the regional landscape. And the result that I synthesize in a very strong way was the first draft of the green and blue infrastructure, composed, taking account the different function of the landscape. So the agricultural one, the natural one, the cultural one, with a different level of intensity of value. Where the value was present to conserve, we need to conserve and to protect. And so including also some action related to the protection of the landscape, but where we need to increase, to enhance the quality and the capability of the green infrastructure to support what we needed to do, so that it's generally speaking a natural-based solution that we differentiated in relation to the different character of the green infrastructure that I was mentioning. So this was the first draft, and this is the final one, where the different color represent the different function of the network, of the green infrastructure network. So you can see in a light brown the agriculture network of the infrastructure, in the green color the natural one, and with more precise dark brown red color, you can see also the cultural component of the network. And in more vivid green color, you can see also the connection, the new connection that we need to implement to complete the network in the regional territory, and specifically in this part of the region that we focus on. This is another, we can say, part of the region, and is a focus also of the green infrastructure network in the mountain region, so in the Alta Valtellina, as an example of what we did. This on the right, you can see some of the components of the research teams that work on this. The second, and I'm going to conclude, is about a local plan. So we worked on a urban plan of a medium municipality in the metropolitan area of Milano. This is the municipality of Oescaldina, is located in the to the north of the metropolitan area of Milano, is about 15,000 inhabitants, so it's a medium size for the region, for the Lombardy region. We work, try to tackle some goals that are the goals that you can read in this slide. First of all, limiting land take process that was very intense in that municipality, but as in the other part of the metropolitan, the northern metropolitan area. We work on the urban regeneration strategies. We try to improve the quality of the open spaces in order to increase the human well-being, and we focus our action on the ecosystem service production, using the green infrastructure and the nature-based solution as tools to work to to achieve that goals. This is another very synthetic images that try to represent the work we did, starting from the ecosystem services, the different ecosystem services regulating and provisioning mainly in the municipality area of Rescaldina, the habitat quality, carbon sequestration, water yield, sediment retention, soil erosion, combining this mapping of these categories of ecosystem services with the cultural services and the pedestrian roads and paths within the municipality. And to the right, you can see the first draft of the green infrastructure, the local green infrastructure that is, I have to say, strictly related to the larger one that is the provincial, the metropolitan one, and also with the regional one. So the relation between different scales. And with different color, you can see the different vocation of the green infrastructure and the different characters. And with the different intensity of the color and also with the different patterns, you can see the different actions that are related, the category of actions that are related to the design of the green infrastructure. And in this sense, the nature-based solution that we provide within the plan, and so what is important that is the green infrastructure is a component, is the strategic component of the urban plan tool. These different nature-based solutions are differently located in the different part of, if I able to come back, this one, are located in the different part of the green infrastructure. Okay, and so it's not everywhere possible to do everything, but what we need to do, where we need to deimpermeabilize the soils, where we need to improve the green coverage, where we need to create a new usability or new production for the rural landscape and so on. Different action in relation to the different component of the green networks. This is a last picture I like to share with you is about the strategic document of the plan, of the urban plan, where the green infrastructure, green and blue infrastructure is the main, the principal structure of the project, focusing where are focused all the strategic action that the plans try to achieve to implement, to achieve the main goals of its strategies. Now I leave the floor, the virtual floor, to Silvia Ronchi, that will present the second part of our presentation, how we try to use the ecosystem service mapping and assessment in the MB South project, and specifically in the Paranoa analysis to support the following design of the new green infrastructure and also of the project of the open spaces of Paranoa.
Thank you, Professor Arcidiacono, for setting the framework, so I can go directly into details of the analysis. I would like to present you some first advancement on ecosystem service mapping for setting and defining and designing a green infrastructure strategies. I would like to present you some first advancement that we are doing together also with Andrea Benedini and Giulia Castaldo on the framework of ecosystem services. I would like to start with the definition of our methodology, so that is divided into 3 different steps. The first one is the definition of the ecological functional scale for mapping and assessing ecosystem services that we define considering some relevant territorial dynamics, and also taking into account the multiscalarity of the ecosystem services approach. So trying to define a large territorial scale that we can arrive until a local one that is useful for the definition of solution, also nature-based, that can increase the provision of ecosystem services. The issue of the scale is very, very relevant, also taking into account that ecosystem services is scale dependent. So we need, first of all, to define what is the best scale, the most suitable scale for our purposes. The second steps regard the ecosystem service mapping and assessment. So we defined what kind of ecosystem services are functional for our project. And in combination of these steps regarding the mapping, we have also in parallel a co-design, a co-creation process that we carry out in September together with the University of Brasilia through different workshops together with the citizen for collecting different information regarding critical issues, problems, threats related on a specific context of investigation, that is the district of Paranoá. And the combination of these two information, so what the output from the ecosystem service mapping step and the co-creation, allow us to have all the useful information for designing a green infrastructure strategies, taking into account also in this case the territorial and the local scale of our strategies. So during my presentation, I would like to present the first step and the second one related on mapping, and the other one are now in progress during the next.
Yes.
So the scale of definition. So we decide to consider the subwater and the water basin as functional for assessing the water regulation cycle. So we defined that according also with the research group of DICA that is involved in the project, and we are exploring the water issues and all the different aspects related on these natural components. So this is the scale of the definition is more or less of 30,000 hectares. That is the white one, but obviously that for this area, we have a greater degree of details of data and information, but we take into account also the surrounding for have a complete overview of all the dynamics and the context relationships. So first of all, the first step for mapping ecosystem services was the data collection. So for using one of the most considered software for ecosystem service mapping, that is Invest, we need to have a very precise and detailed land use and cover information. We start from this kind of information that is from 2019. We derive it from the geoportal of Brazilian authority. But the definition for our purposes is not so good, is not so, the geometry is not so appropriate for our purposes because we can't have the permeable cover inside the urban area that is fundamental for having a complete provision of ecosystem services inside very sealed area as Paranoá and Itapuã district. So we decide to create our land use land cover, so the land use land cover from MB South project. So we download the satellite image from Copernicus program. We create our land use land cover starting from the satellite images. We use the superval classification analysis, and we integrate this first step with OpenStreetMap information and other information we download from Brazilian geodata portal. So the definition is very relevant for us and allow to have a combination of information that allow us to have also the distribution of permeable surface inside urban areas. In the circle, you can see the differences from the first layer of land use land cover and what we have now for ecosystem service mapping. So we have the permeable cover, but also the differences between buildings and infrastructure that is fundamental for different ecosystem services. We have also differences in the natural area, so we can have the distinction between natural, grassland, or rural area that is now that is not in this case from the first land use land cover database of 2019. So these are two different pictures that can help you to understand the context of investigation and why it's important to have also indication of the very scattered green areas inside the urban one. So the sealed, the soil sealed amount is quite relevant. but we need to have also this very residual, very small and poorly vegetated area in order to try to valorize and to address strategies also for this kind of area. Inside the step 1 of the data collection, we also calculate the NDVI, that is a value that estimates the vegetation health linked to the density and the productivity of the vegetation. And we calculate comparing the absorption and the reflection of the NED, the near infrared light made by vegetation. And we create this indicator considering 4 different images that we download from Copernicus program that are related to for each different season that we have in Brazil. The NDVI was included in the land use land cover. It was useful also for running ES modeling, especially for the habitat quality. That is the first model that we run. And all the models were run using Invest. So this is a software developed by the Stanford University with the collaboration of Minnesota University, WWF, and the Nature Conservancy. The habitat quality you can see also in the slide. The definition is the ability of an ecosystem to provide good and appropriate conditions for species. And is an interaction between the habitat suitability of land use land cover, some threats that we identify, and the level of impact and the different of each different threats to the quality of the habitat. The output is this map at the larger scale, and what we can see is that in the eastern part, I don't know if you can see the arrow of my mouse.
Yes.
There, okay, is the area that have a higher quality of habitat, and obviously is because this area is not affected by urbanization process. Also, the very lighter one are rich, so the quality is maintaining also for this motivation. But we have a very decrease and maybe also a lack of quality of habitat where the space is totally urbanized. If we see if we zoom in into our 2 different case studies, so Paranoá, Itapuã district, what is interesting is the gradient of influence of urban areas that affect the natural one. So the color, the light purple until orange, highlight the space that can be involved by strategies, for example, NBS strategies. So trying to create solutions that can mitigate this impact and better enhance the context, the natural context that we have, that we can to valorize and protect. Another model that was considered is the stormwater management. So it's an estimation of the major hydraulic flux in the urban stormwater balance. So trying to estimate the potential fates of the precipitation, so the incoming precipitation, and how the precipitation falls on pervious or impervious surfaces. The process that results in water retention includes, for example, the interception and transpiration made by vegetation covers, the infiltration, so the propensity and the capacity of water to drainage into soils, and that can also recharge the aquifer, and also the evapotranspiration. So the amount of water that is not subjected to these processes determine what is called the surface runoff. So we model the surface runoff, so that is the volume in terms of cubic meter for year. So we have a very precise value, an amount of stormwater that is not retained by soil for each pixel of these images. And we can, also in this case, if we zoom in, we can see the runoff distribution in our 2 districts. And we can see that the level of runoff is quite important because of the very impervious sealed area that we have, and that that is important to consider. And also we have different permeability in the amount of runoff outside the urban area, and this variability depends also on the pedological characteristic of soil and also on the relative texture of soil in terms of sand, silt, and clay that change the capability of soil to retain water. This output is useful to understand the water accumulation area and also for setting the appropriate strategies to reduce the impermeability and to increase the water percolation, avoiding pluvial flooding phenomenon, and try to increase the resilience of specific area of our case studies. We are also developing together with DICA department other model, more refined than that is called soil water balance model, but we are ongoing for these activities. The last ecosystem services is the urban cooling, so the capacity of ecosystem to provide to avoid the increase of temperature. The urban cooling express the capacity of ecosystem and refer to the phenomenon of, so the urban heat island is the inverse phenomenon, so in which urban areas have higher temperature compared to the surrounding natural areas. The phenomenon depends on the combination of different aspects, is strongly influenced by urban design, in terms of permeability and permeable surfaces, but also the urban morphology. So the physical structure of the built environment influence very strongly the urban heat island, the use of the material, the amount of green spaces, and also in addition, the air pollution that depends for car traffic, and also the heating system is very relevant for trying to contain this phenomenon. The output, okay, is the cooling capacity. So the results show us important difference between rural and urban area, with a particularly high temperature inside the district of Aitapoa, which require a rethinking of the urban morphology, acting transversally on all the components that I mentioned before, trying to have a very strong design project that can reduce the increase of relevant temperature, especially during the summer season. So I arrived just in the end of my presentation, trying to show you some first proposal of MBS. The selection of the MBS is made considering the feasibility of the intervention, basically on the land use and cover that we have, and also the availability of the space that we have in our two different districts. So the first one are the package of action that are under the name of green over gray, so something that can be placed on buildings like green roof, green wall, green shelter, green facade, and all the things that you have in mind. And this kind of action can be created for new building, so new intervention, but also on retrofitting buildings, for trying to increase also the capacity of the existing cities. The second MBS that we can suggest for avoiding for enhance the quality of the spaces are this kind of very small pocket intervention, like a sort of hotspot of green smaller spaces that in a capillary areas we can create a cumulative effect. So very, very small area that now have, I don't know, the lack of vegetation, maybe without trees, for example, we can try to increase the quality of the spaces with an increase of the canopy cover that can create a cumulative effect for increase the cooling capacity, but also for increase the capacity of a space to host species, to increase also biodiversity inside very impermeable areas. Another MBS is the change of the materials, trying to use porous pavement that can increase the percolation of rain, so the percolation of water, trying to replace the current flooring that now cover the majority of the space that we have. And another proposal of MBS are the construction of salt trenches, so drum filters that can increase the capacity of soil to drain the water during, for example, intense rainfall, but also create a good condition for habitat for species. So a combination of multiple function of ecosystem. The last one is the implementation of maybe some rain gardens that are that can be implemented also in very, very small area and can increase also the quality of the spaces, so the quality of the landscape in urban spaces, and can collect a good amount of water that in other case can go in runoff, in surface runoff, so causing the problem of fluvial flooding that we mentioned also before. I just arrived until the end, so there are some initial results for the ecosystem service mapping and some suggestion of possible strategy that can be implemented in consideration of the characteristics that we have in our context. So if you have any suggestion, comments, they are very, very welcome.